So I think there's probably 3 or 4 challenges that are key to EV uptake. I think the first is power, management of power networks. An EV, when it's charging at full whack just at home, draws 7 kilowatt of power. Just putting that into context, so that's effectively 2 ovens and a kettle working full whack, going on for 9 hours, and that's literally just one house.
Welcome to Bite Size, a series where we highlight innovation across transport, mobility and smart cities and meet the people that are making it happen. My name is Emily Bobbis. I'm a road intelligence startup founder, and my goal is to combat the stigma that transport is uncool, uninteresting and uninspired. Well, David, thank you so much for coming onto the podcast to chat today.
Oh, no, thank you. No, really looking forward to it. I'm always listening to podcasts, but I never get a chance to be part of one. So there you go. There's a first for me anyway.
Lovely. I'm glad that we can help facilitate that. I was hoping to start off by getting you to tell us a little bit more about your story. So what's your background and what are some things that you're passionate about?
So I live in the north of England. I don't know how international this is, so I've pretty much lost most of my northern accent. I can put it on if I need to, but yeah, I live in a city called York, so quite a historic city. So for me, I've really been into this sort of space, transport decarb for quite a long time. So studied randomly, I'm not an engineer by trade. I studied history at the University of Edinburgh, and then went into transport at a fairly youngish age, sort of as I graduated out of uni. And then off the back of that, found that the big space that was growing and the space that was having a major impact in terms of transport planning was around this whole decarb space. And funnily enough, my degree that I did was actually transport and economics in history. So a lot of the work that I actually ended up doing at a degree level, although it seems really not linked on the face of it, actually started to play quite an important part, because ultimately I was very much looking at data and how data links back to sort of economic growth. And ultimately we're in this space now where EVs and the adoption of EVs and this push towards decarb and decarbonisation is very much driven, or will be driving economic growth going forward. So funnily enough, on the face of it, people go, well, he's not an engineer, how can he have any view on this? And I'm like, well, yeah, you guys sort out the electrics of plugging in the chargers and stuff, let me do the strategic stuff, and that's really important. I'm not saying it's not important, but you guys do that stuff, and I'll look at the strategic. Okay, how do you put chargers here, how do you maximize adoption, how do you encourage people to move away from cars where possible? Obviously I know you're based out in Sydney, and there's a really good program over there to get people onto mass transit and what have you via the trams and the various train networks and stuff. But in urban areas where the car is needed, it's all about making sure we've got the chargers in the right place. So my passion is very much about that.
So you are currently also part of a company called WSP. Did you want to give maybe a brief little background about what they are and the problems that that's aiming to solve?
Yeah, definitely. So WSP's a global consultancy. Again, they're pretty much everywhere. I'm sure they have offices in Sydney and Australia, offices in Europe, the US and the like. And the company's very much focused on providing professional consultancy and engineering services and things like strategic advisory, design services in a range of areas. So that can range from things like transportation, which is obviously my space, infrastructure, environment, building, power, energy, water and resource. Ultimately, as we're starting to see this move towards greater sort of environmental resilience, you're starting to see all of these consultancy services that might have been separate in the past packaged together. And ultimately, that's meaning that as a consultancy, we're able to offer a full end-to-end. Yeah, quite an exciting consultancy to work for.
Love it. So, so you mentioned, to steal your word, decarb. I've never actually heard anyone shorten it like that, and I kind of like it because Australians like to shorten most things, so it works out quite well. So decarbonisation or decarb and net zero are two like super hot topics in transport, as you've alluded to, and as you've also alluded to, a lot of governments have kind of included electric vehicles as part of their plans and strategies to tackle targets around like reducing emissions and sustainability. Are you able to maybe set the scene a little bit about, say, electric vehicle uptake in the UK through maybe some of the key stats that are floating around, or even some of the policies and the targets that are kind of being driven forward at the moment?
I'll talk about two key geographies really. So Europe, so the EU 27 minus us. Let's not go into that one. I won't share my political colours on that. But anyway, and then the UK. So there's two separate stats, and I like to keep those two together because ultimately, even if we are in a separate governance setup or what have you, the trajectory for Europe and the UK are fairly similar, and you'll see in the stats. So. I've taken 2022 figures because I think obviously 2023 is happening. 2022 is obviously a full year of data. So in the EU 27 in 2022, battery electric vehicles accounted for about 13% of all registrations. So that's about 1.3 million vehicles. So that's new registrations. And there's everything from like a private buyer going to a car dealership and buying an EV, all the way through to leasing and company car usage. And in the UK, as I say, the figures not too dissimilar. So again, 2022, battery electric vehicles, 12.5% of our registrations. And that's about 14,000. So obviously a smaller market, but the same percentage. I've deliberately excluded hybrids here, just because that massively complicates the sort of adoption of lower carbon transport modes. So really, that's the adoption rate. And what's driving that? Well, the UK has set a target of not selling any petrol or diesel cars by 2030, and the European Union has set that to 2035. Now, there's rumours in the UK that might be shifting to 2035. The adoption rates are maybe not where they need to be, and there's so many factors to talk about, and you could do a separate podcast on that on its own, so I won't go into that. But ultimately, that's pretty much where we are in that space. So there is a growth. We're talking about 10 to 15% worth of cars registered, and the other thing that's happening is you're starting to see more of the cars that were bought in, like, or leased in from 2017 onwards, that are actually fairly robust, good quality cars that are actually starting to come into the used market as well. So the used market's picking up as well. So there's now a segment for everyone, not just new cars, in terms of EV usage.
Super interesting. I'm very interested in this as well, because Australia is lagging quite behind in our EVs because we don't have any fuel emission standards or any national policy strategy actually either. So it's kind of interesting to see what's happening in Europe and the UK, who are a lot further ahead, I would say, in the policies, but also the actual implementation stage as well.
Exactly, and I think the challenge is, we have to look at the geographies as well that we're talking about. And the challenge here is it's very easy for everyone in Europe or the UK to be like, oh, well, we're so far advanced, when you look at the US or Australia or New Zealand for that matter. But at the same time, some of the journeys that are done in Australia, the distances, obviously, it's so much of a bigger country, and you need vehicles with longer ranges. Range anxiety will be an issue more because the distances that people will want to use their car for are just so much longer. But it's also about what we call particulates that are also generated from brake wear and tear. And whatever happens in those instances, even if you have an EV, that's still an emission factor that you can't really get away from. But the legislation still needs to target that.
I think a lot of people treat EVs as some kind of silver bullet to solve all problems associated with ICE or internal combustion engine vehicles. So it's kind of nice to balance it out a little bit and know that we're not saying that these are a be-all, end-all kind of situation. I think you also talked about the idea of like how these shifts will affect different groups of people in different ways, which leads very nicely to the next question about what challenges does electric vehicle uptake present, and to whom?
So I think there's probably 3 or 4 challenges that are key to EV uptake. I think the first is power, management of power networks. An EV, when it's charging at full whack just at home, draws 7 kilowatt of power. Just putting that into context, so that's effectively 2 ovens and a kettle working full whack, going on for 9 hours, and that's literally just one house. And that's the equivalent of 3 houses, effectively, if you think about it, or 2 houses. So you've instantly sort of doubled, or in some cases tripled, your power draw. And that is on top of the energy network, which is trying to move away from power sources that are not sustainable themselves, because ultimately, the danger is you can quite easily greenwash your credentials by saying, oh, I'm obviously charging my car at home. But if your power is being drawn from coal power plants or gas power plants, then ultimately you're not actually being that green, are you? You're just shifting with decarbonisation burden to somebody else. So what that effectively means is that the power network has 2 challenges. One is smoothing the curve, so trying to encourage people to charge at different times, making sure they're not charging at peak times, which again is fairly standard in most countries. The working pattern's fairly standard. So the power network needs to adapt in terms of managing the load and also becoming more sustainable in terms of wind power. But at the same time, the wind doesn't always blow in the same way that the sun doesn't always shine. So you need to be able to find a way of basically managing that power. So that's one area. And I think the other one is this sort of equitability of EV adoption. You'll see most of the EVs on the market are pretty much at the upper end of the sort of purchasing scales, quite expensive. And ultimately, they are sort of pricing out a lot of people in terms of the EV space. And the challenge there is if we're not careful, you're going to have a sort of a twin track route of people who can afford EVs, adopting EVs, and doing so because they can afford it. And then those who probably really need to switch to EVs because they probably have the older vehicles that are more polluting. And this is a terrible generalisation here, but those from lower to middle income backgrounds will struggle to decarb because most EVs are quite expensive as a whole. And the challenge is you then start saying, no, there are affordable EVs on the market. And I'm like, okay, there are, but the rule of thumb with an EV is if it's cheaper, it usually has a smaller battery, which then reduces the range, which then you start getting to this whole sticky space of effectively saying to people, well, you can afford a smaller EV, but you're going to have to spend more time driving to charge it. And also, when you're charging it, you can be waiting longer because chances are that EV doesn't have rapid charging technology in it. The adoption piece needs to be more equitable as well. So does that mean more support or better support for charging infrastructure in local areas which are not as affluent as those other areas where there's a high level of EV adoption? Yes. That, for me, the power and the equitability piece is really the critical bit that we need to crack.
Yeah, it's super interesting as well, because I hadn't considered the equitability of adoption argument, which is super interesting. And it does, again, lead quite nicely to the next question, which is like one of the, the beefiest challenges that we hear about with EVs, or at least as we're encouraging the adoption of more electric vehicles, is the infrastructure to support that uptake. So you've mentioned this idea of 2 ovens and a kettle, and then there's all those arguments about where do you even place infrastructure, how much needs to be public versus private, and all that kind of conversation. And this kind of ties back in. You recently did a presentation about EV charging utilization modeling. Before we dive into it, I just wanted to get like a clear kind of overview of what is utilization modeling, so we can kind of start from the basics and build from there.
Utilisation modelling is all about understanding the likely usage pattern of a charge point. It seems really like common sense. Actually, maybe it isn't. I don't know if we think like this. So, like, if you buy an oven or you buy a TV, you don't necessarily think of the usage patterns and the deterioration of that, but also the power drain. But when you're investing all of this money in terms of infrastructure, and in the UK, a charge point can cost anything between the charger, the bay it's sitting in, the power connection, all of those things can cost anything up to £8,000 to £15,000, roughly. To understand how you're going to get your return on investment, you need to understand how often it's going to be used and that usage pattern, how that translates into an income. So what utilisation modeling effectively does is says, okay, well, you've got a charge point here, or you've got a proposed charge point here, realistically based on the local demand, i.e. the local number of people who are probably going to be using it, what's the usage pattern over the day? And how does that translate into power drawn? And then ultimately, once that translates into power drawn, how does that then translate into income? Because ultimately, every kilowatt drawn is 55p potentially that's charged to the customer, and potentially 30p of that is needed to service the debt of building the charge point or cover the power cost, all of those things. So it's about balancing all of those things in a model so that when we're deploying something or proposing a deployed location, we can say with a degree of confidence or a degree of understanding that that location will likely see good uptake. Because ultimately, if you don't do that, then you end up building charge points in places that just actually don't get used.
So how have we decided where EV charging infrastructure has been placed up until this point? Or is that kind of also part of the challenge?
That's a great question. So I think to date, primarily most of the deployments have tended to be driven by a bit of a build it and they will come mentality. So ultimately the sense is that if you build it here, chances are people will use it more. Also factoring in the practicalities of installing an EV charge point. Now, as I said about that power drain piece earlier on, I'm sort of mashing all the different charge points into one. And this is the other challenge of the whole discussion. But these discussions, I tend to think of 7 to 50 kilowatt because that's mainly the ones that are getting deployed. I mean, there are tons of rapid and very rapid, ultra rapid chargers being deployed. But they tend to be in motorway and sort of highway type environments. In terms of those slow to fast chargers or fast to ultra fast chargers, that ultimately the whole piece to date has very much been like, well, there's capacity in the local substation here. There's an idea that's going to be demand, because it's a shopping centre, or it is near a gym, or it's near a cinema, or it's in a fairly busy area. So if we build it there, it's probably going to get used. Problem is that doesn't really analyse the likely usage patterns, doesn't really understand what people are likely going to be doing and how they're going to be charging and when they're going to be charging. Going forward, if we're wanting to understand and help people make that adoption, then we need to make sure charges are in the right place. And the only way we can do that is by modelling. You secure your investment because people will see, or investors will see, well, actually, that is profitable, so I'll invest here. And therefore, more charges get installed, so there's more available, so more people use it. So you get this self-fulfilling cycle.
I'm really curious about what kind of data inputs have been used for this demand modelling so far, or are finding and procuring not only data sets at all, but just quality data sets for utilisation at scale also part of the challenge in this expansion?
Yeah, the data piece is difficult. And again, I can only really speak on the sort of UK and Europe geography because I know different geographies have different data sets and the access to it. So it's a fairly Western data source, but the Experian Mosaic data is effectively what gives you an idea of sort of consumer analysis in terms of postcode and regional sort of neighbourhood level that then enables you to understand, okay, certain areas will have either a propensity to likely uptake EV or an actual uptake based on registration. So you've got this mosaic data that gives you like personal data, demographic data on top of that gives you an idea communities and what have you, and that tends to come from multiple sources. That's a sort of demographic data. Then you then start getting into the whole trip and people movement data. Tons of sources for that, and that's where it can get quite pricey. So the Experion like mosaic data is one source that can be costly but not that expensive. The sort of trip data that can be derived from things like mobile phone data or ANPR, so automatic number plate recognition, then gives you an idea of, okay, how busy is a certain road and the type of vehicles going down that road. So that data then gives you an idea of demand. And then the other point as well that's really interesting from a data perspective is using any form of GIS data, so geographical information system, so like spatial data for things like planned developments, housing density, shopping centre, local workplaces, parking regulations, all of those things. And then you start to get a really good picture of an area and the likely adoption of EV and how they sort of play a part in terms of an area and how likely people are to adopt them. So those sources all together can give you a real good idea of people demand and power demand. And then once you have that, you can then start proposing locations and then working out what a utilisation might look like in those locations.
Yeah, wow. It sounds like there's a lot of moving parts in this, probably more than I had actually realised.
Yeah. And the thing is, you've got to have a really robust tool first and foremost. But what's really fascinating with this whole space and the whole transport data space is, historically, when we've looked at transport data, we've always looked at it from a sort of a reactive perspective. So, you've got traffic moving around transport networks, and you put in traffic lights or you monitor traffic flow and then work out where and how to change that flow to suit a specific traffic flow model or to satisfy a certain need in a certain community. Whereas with the move towards EV and this whole EV infrastructure adoption, we're in this first position where we can actually be more proactive in terms of trying to install infrastructure in places where we think people are going to need it and be ahead of the curve. And that's the exciting bit, in my view. I think ultimately it moves away from this whole model of where you sort of build petrol stations and pretty much people will use them, whereas EV is very much a case of, well, actually, in the UK, we need 300,000, if not more, chargers by 2030 just to meet some of our targets. And if they're not built in the right place, then we are going to meet our target, but we're not going to actually deliver decarbonisation. So, yeah, fascinating space. The data-driven piece is probably the bit where the greatest bang for your buck is probably going to occur, really, I think. But also making sure that people can actually adopt it.
Do you have a real world demonstration of how utilisation modelling can be or has been deployed?
Yes. So the project that we were doing, we were working with a private investment firm to do a due diligence on their investment in a charge point operator. I'll shorten it to CPA for now, just because it's a bit of a mouthful. And what that effectively involved us doing was where we looked at each of those locations and tried to work out, okay, what sort of demand profile are you looking at? So some of the locations where the charge points were installed were at shopping centres. Some of the locations where they were deployed or installed were at supermarkets. Some of them where they were deployed and installed were at like gyms and hotels or just off the motorway. What that effectively meant was we then had to work out, okay, well, we needed to work out the likely demand, the realistic utilisation using their existing data, and the proposed utilisation. As soon as we started getting into that, we discovered that the way in which utilisation was being measured wasn't necessarily how we'd expect it. So they were measuring utilisation as charge per day in terms of the length of charge and the power drawn, but they weren't differentiating between a plugged-in session and an active session. If you use plugged-in session versus active session, then you can have a car plugged in for 10 to 15 hours, but it topped out its charge by hour 4 in that period. So you've now got a car that's looking like it's using your charger, but actually it's not drawing any power. We proposed to the CPO that their utilisation model should actually be based on what we anticipate as the average potential maximum power draw from that charge point per day, and that's built on a number of factors. And what we said to them was actually, well, if you apply it to this use case here, which is like charging at a hotel, you'll see what I've just explained there is having a major impact on your income, because ultimately you do have cars that might actually get there fairly depleted in battery, but sit there all night. In this specific use case, they hadn't put in an overcharge fee, so there was nothing stopping people from charging all night, but not charging because their car was already full. And we said to them, well, actually, if you use this more accurate sort of utilisation calculation, which bases power drawn by each charger on, I don't know, the likely usage pattern, but also the realistic sort of like draw based on that location, then we then said to them, well, ultimately, can you encourage, in this specific use case, can you encourage people to charge during that period and then unplug their car, or can you encourage them to sort of top up their car in that period and then unplug and then plug back in the morning when they get up, so that they're not blocking the charger? Because there were some use cases where people were getting to that hotel quite late and actually wanting to charge overnight. So all of these things in that specific use case demonstrated that actually, if you understand the likely utilisation pattern of that location, if you use the right data, ultimately their model was telling them the wrong thing. It was telling them that site was being utilised really well. If you understand your data and if you understand your usage pattern and your demand, then you're going to get a better view in terms of how people are using it. Really interesting use case, hotels, also shopping centres and any place where people are leaving their car for a very long period of time.
Yeah, that is super interesting, because I hadn't even considered the difference between if someone's actually plugged in and actively charging their vehicle versus someone who's just parked there and their car finished charging 6 hours ago.
Yeah, exactly. And it's you can see it in the data, so it's not like you can't identify it, because it's as simple as the fact that most of the data generated by charge point operators you can pick up those points. Ultimately, any car that's plugged in not charging isn't making you any money, basically. It's just blocking the charge point. It's another form of icing. I don't know if you've come across the term in the industry, but the whole idea of icing is like internal combustion engine parked in a charging bay is effectively icing that bay, because ultimately no one who's an EV can charge it. But you have this sort of like EVing, which is effectively where you have an EV blocking it but not charging, which is also a problem.
I have come across, I think like only 2 weeks ago, actually, the term icing, and I really love it. I think it's such a fun, not a great experience, but a really fun kind of term for that behavior. So it's really quite cool. In terms of my next questions, I really like these last ones. I try and always keep some fun ones to last. This one is, there's a whole bunch of innovation happening in EV charging and also just decarb in more general terms. What innovations are your favorite or that you're most excited about?
I wish I could say hover cars or stuff like that, because that, you see, hover cars would be really good, because that would get rid of your tyre wear and tear. And it would also, in theory, get rid of your brake wear and tear, which would make vehicles fully emissions free, in theory. So that would be the solution. But realistically, the less sexy, less fun innovation is probably vehicle to grid. I always have to caveat this, because it needs to be controlled vehicle to grid, because the challenge with vehicle to grid, the exciting bit about vehicle to grid is, I mentioned that whole problem about flattening the curve in this whole power draw. If every house in the UK had a, don't quote me exactly on these figures, but if every household, and let's say you've got 18 million households in the UK, had a 50 kilowatt car sitting on their drive, that is many kilowatt of battery capacity sitting, literally not being used between, realistically between 8 or 9 p.m. and 3 a.m. in the morning. The whole point of vehicle to grid is, can you, as a power network, tap into all that power that's sitting there and actually use that to flatten the curve? So ultimately, if there's loads of power being drawn from the power networks, if you can collectively draw it from a fraction of those vehicles to no longer need to turn on a gas power station to meet the gap in, or coal power station to meet the gap in power generation, that will revolutionise power management. But, and I always say there's a but to this, it only works if you've got really good systems that can manage it, because I would be pretty peeved if I came down at 8 a.m. in the morning and found that my battery had been fully depleted. Everyone around the street's really happy because they've had their kettles on, they had the oven last night, someone's watching, I don't know, The Crown or The Last of Us, and waited late into the night watching that and using all my power, whereas now I can't get to work because my car's literally sitting there depleted. And I joke about that, but actually there has been times where I've not fully set up my own charging setup in the evening and it's not charged in the morning. The systems need to be really robust if vehicles grid charging. Robust enough that it doesn't do silly things to your battery. And the other point, I'm being really negative about this innovation. It is an exciting innovation, but I'm just saying that there are some things with the innovation that need to crack. The other one is having the honest and open conversation that every time a battery is depleted, and recharged again, it will reduce the life cycle of that. It will not reduce the life cycle. Well, it will reduce the life cycle of that overall battery. Every drain has a small incremental damage to the battery. Now, if you're increasing your drain on the battery from once a week to every night, that's like a threefold increase in the number of charge. It's a threefold increase in the number of charges that will have an impact on your life cycle of your battery. So it's things like that we need to have open conversations about. I'm not saying that that's not an issue, but it's something that people need to understand as well.
That's good. I think it's a realistic take. And the main takeaway as well is it's a lot of ovens and kettles happening in the background.
And also, I suppose people need to feel that they're being incentivised. So in the UK, and actually they're getting quite big now globally, well, they're gradually becoming more global. There's an energy company called Octopus. We've just joined them. Really interesting because they're using data. They're pretty much basing their entire power model around data. But they've just introduced a new sort of power package that's called Flex that allows you to discharge your battery and then recharge your battery. And the discharge of battery overnight is actually really quite, profitable, because ultimately you could, if you've got good solar power going into your house, you could potentially generate a small profit from your solar at night by exporting the power that you've got sat in your battery and in your car back to the grid. And then the next day, rinse and repeat. If it's a good sunny day, fill it up again. The only problem is the UK is not the sunniest, and you guys in Australia have all the sun. So, you should have solar everywhere. How dare you not do that?
I apologise on behalf of all Australians for the unfair equitable distribution of yes, that is that does go back to equitable adoption. But my last kind of official question before I get to the one about how people can contact you is what's a question that about this topic that you kind of wish people would ask you more often?
So again, this is really UK focused, but I've just come back from a conference where we've had this massive debate, and it was fascinating, where there was just like this whole two different views in the room between the CPOs and the EV drivers. But the question I'd ask, and it's almost like one to generate the discussion, is why can I not pay at every charge point with my contactless card? Why do I need to have another app on my phone to pay for charging? And why is it, it's a second point to it, it links back to it. And why is it, if I've got an app on my phone, why on earth is it set up in such a way that you auto charge me for a period of time, i.e. in the future, like taking 10, 15, £20, when I could then have that sit on my charge card for possibly weeks or months because I only use your card infrequently, I charge point infrequently. So why can I just not pay every year with contactless? And also, if I'm paying by contactless, why am I being punished with a higher price versus your preferential app-based charge?
Yeah. Oh, maybe I should have asked that question earlier in the podcast and then just scrapped all my other questions and just.
Yeah. Well, I'm not sure. I'm not sure. Yeah, I just get it. I've been on so many long journeys where we've got our own driveway, we've got our own charger at home and things like that. So we don't have to charge out and about, but at the same time, when we go on longer journeys, 300, 400, 500 miles, which we do fairly regularly if we're going up north to sort of Edinburgh or the north of Scotland, or in those instances, I have to massively pre-plan to know which charge company I'm going to be using on the way, therefore which app do I need to have on my phone, and then do I need to pre-top that up? Is there a period of setting up the app so that it works? All of these things, and I'm just well, if I just get somewhere now and plug in and then tap my contactless card or plug my card in and put my card in and my PIN, it's a lot easier. And it's really funny. I was showing someone. I was meeting with an Egyptian delegate at this conference, and they were basically there on the journey towards rolling out EV infrastructure, and they were like, "Oh, there's only three charge companies. Why do you insist on?" They were like, "Why do you insist on people paying by contactless?" So I go open this app that we have in the UK called ZapMap, which is really good for just getting a lay of the land of all the charges, and then just scroll down and kept scrolling on my phone and then kept scrolling and then kept scrolling and then kept scrolling, and I'm probably there for maybe 15-20 seconds of just trying to scroll down, and I'm like, oh, so that's all the charging companies, and each one of those has an app. So they were like, okay, so have you got all those on your home screen? I'm like, I just scroll right on my phone to all the way through the home screen. I was like, yeah, there they all are, taking up 15 pages of my home screen. So yeah, it drives me mad.
With reason, though. I mean, it sounds like a very frustrating UX kind of point of friction, which I'm sure if there's anyone listening who wants to have a problem to solve, that sounds like a very good one.
Yeah, and there's a thing called roaming, so that where you've got one card for all chargers, and there's a lot of companies getting into that space as well. So there is a solution to it, but then you still have to have another card because you have to subscribe to that roaming company. So yeah, and then they don't have the same rates. Just if I go to a petrol station, I don't have to have a Shell payment card or an Esso payment card or a MGF payment card. I just pay with my contactless card, and and people are like, oh, don't compare it to fuel. I'm like, yeah, but that's one use case where you should compare it to fuel. It's like people want to pay in the easiest way. That's not something difficult to ask.
I'm sorry that I've asked you that question now, actually. You're getting real stressed for first thing in the morning.
yeah. Well, it's fine. I've got a coffee. It's all right. It's fine. And the kids are away today, so that's all good as well. So I love them.
It's a win all around.
Yes.
So my last question is, how can people connect with you, or where can they go to learn more?
By all means, you can drop me a mail. So my email address, and I'm guessing you'll pop it in the spiel of the podcast, whatever you got. It's david.trousdale@wsp.com. And then to find out more about WSP, you can just bang in pretty much WSP.com, which will then take you to whichever region you're in, to give you a bit of an idea of the company that we're working for. You can also find me on LinkedIn. So again, it's david.trousdale, and you'll find you should pretty much be able to work it out. But I'm a transport decarb technical director within WSP. Or if you're a charge point operator and you want to have a rant to me about why it's hard, then by all means do it.
Excellent. Good. Wide variety of audiences with their problems in there that could contact you about different things.
Perfect. Awesome.
Well, thanks so much, David, for taking your time out and being on the podcast today. It was a super interesting conversation and nice to get a little bit of a UK perspective as well.
No, thank you. Thank you for your time. And as I say, hopefully looking forward to the advancements in the Australian market going forward as well.
If you'd like to learn more about any of the guests that we have on the podcast, more about Bite Size, or more about Compass IoT, the company that produces this podcast, you can visit our website, which is www.compassiot.com.au. Until next time.